My name is Ishan Nand. I'm VP of Product for the application side over here at Edgio. And my co-host is Anthony. I'll let him introduce himself.
Hello. I am a developer advocate at Edgio. And yeah, super excited to be here. Thank you everyone for joining.
Yeah, and one other note here, if you want to know what we'll be probably talking about, although we never know because it's an open mic night, we have a newsletter to keep you informed about the latest happenings in the web development and JavaScript ecosystem. Usually is a source for a lot of our discussions. That goes out once a week and has the best from around the web as it relates to JavaScript. If you want to sign up for it, I highly encourage you to go to javascriptjam.com and you can sign up right there on the front page. You can also see our previous archive of past newsletters. You will note there is a step function improvement starting in January when Anthony took over, started writing them, and I'm really proud of them. I'm really excited he's here and what he's done with the newsletter. So I highly encourage you to take a look at that. There's videos, there's podcasts. With that, Anthony, was there anything that jumped out at you when you were putting together the newsletter that you wanted to highlight especially? Or I'm happy to go through and tell you the things that jumped out at me from this week's newsletter.
Yeah, I think we'll probably have a similar one because it both aligns with our own personal interests and our kind of work relations, as well as the Shopify functions, which is going to be using WebAssembly and some things called Jobby and Quick.js, which I don't know a whole lot about, but I would be willing to bet you at least a little something.
Yeah, so I saw that. I was really excited. Shopify's had kind of a long history actually in WebAssembly, and they were using it and adding it to their system even before they started building the hydrogen and oxygen system, just as a way to make the system more extensible. So for the audience here, just set some context and some stage. So Shopify, of course, is a e-commerce platform, and their key differentiation is that brands can come or stores can come and they can build their experience on Shopify, and most of the heavy lifting is taken care of from them, and they just get to customize the experience to their customers, the people they sell to. Unlike, say, on something like Amazon, where every single product page looks the same, every single category page looks the same. As a brand, you cannot stand out and differentiate. And the big need that their customers are facing is how do you take that to the next level? They need to customize the experience even more, yet they're still on a very unified, everything built for you platform. So how do you handle that tension between bundling as much as possible the merchant to create so that they don't have to do any heavy lifting, but then where they want to break out of that sandbox, you want to give them the ability to customize? And how do you manage those trade-offs and that tension? And so obviously you need to build some ability to have some level of customization. And they have a way to do that through liquid templates in Shopify. That's their markup language. But you ran into this problem where people wanted to customize the backend logic inside the platform. And then, as it started happening over the last few years, they want to run what are called headless experiences, where they're using Shopify just as an e-commerce backend platform, but the entire front end is on one of these modern frameworks like Next or Nuxt. And so that's why they started building out the Oxygen platform, as well as their own framework. Hydrogen, although maybe I've got those backwards. No, Oxygen is the platform. Hydrogen is the framework, I believe. Correct me if I'm wrong, Anthony.
Yeah, that's right.
And so one of the ways they look to add the ability to give their merchants a way to run any arbitrary customization code inside this platform was through WebAssembly. So what is the challenge here? So you say you want to give somebody the ability to customize, and when it's not just look and feel like templates and HTML, CSS, but when it's actual logic like JavaScript running in the back end, now there's this whole security aspect to it. You need to make sure that when you're running the function for one in the large Shopify platform, it doesn't go and steal data from all the other merchants, and it doesn't starve the resources of all the other merchants. Like you don't have one function that's running an infinite loop and suddenly nobody else can serve customers on that instance because it's a universal platform that anybody can be on. And you can't just give them access to raw V8 or something that they run the rest of their backend logic. They need to protect it some way in a container of some form. Historically, the way you do this is in something called a virtual machine, but there's this new standard, WebAssembly, which lets you run unsecure code in a sandbox that you have security guarantees about, that it's not going to be able to break out of this jail. It's got some other benefits, like it's got really fast or very small, what they call cold start times. It doesn't take a lot of time to essentially start up before it actually starts executing the function, which is an issue.
And that's actually relevant to one of the other links we had in the newsletter, which is a comparison of different runtimes on Lambda and how their cold starts relate to each other, which is really useful, I think, for people who don't work a lot with serverless functions and may not have a good intuition for what is fast or slow and what's a reasonable cold start time.
Yeah, that was actually the first thing I was going to jump to, was that one. That was the one that jumped out to me first on there, but we'll get to that in a second. So what Shopify released, which is actually from an ex-Googler, Surma, who has some really great developer-focused content. I highly recommend his stuff, including I think he may still host a podcast called HTTP, I think 203, but they talked about how they brought JavaScript to WebAssembly. So WebAssembly is a format for code that can run in this universal container. It's the write once, run anywhere, as they used to say. So if I write some code and I compile it down to WebAssembly, it becomes this module that any place that says it runs WebAssembly, it can run. And notably, WebAssembly can run in browsers, but it can also run in servers as well. And so what Shopify is doing is they're basically opening up their platform so you can run there in WebAssembly. The challenge historically is that WebAssembly doesn't actually natively understand JavaScript. And so what they detailed is all the work they had to do to be able to run JavaScript from within WebAssembly to enable Shopify functions. And this is, as Anthony mentioned, near and dear to us, because at Edgio, we've actually had various forms of edge functions. There's a couple companies we've acquired. Layer Zero, where I worked at, had a form of serverless. Edgecast was another company that was acquired by Edgio. They had their own Dino-based edge function, and Limelight Networks, which is also acquired or part of Edgio, also had edge functions. But what we're doing moving forward is we're harmonizing the next version of edge functions on WebAssembly ourselves because of all its really great properties regarding cold starts and security guarantees. But one challenge is, unlike, say, V8, which is the JavaScript engine in Google Chrome, which some people use for their edge functions, which natively understands and runs JavaScript, WebAssembly doesn't know how to run JavaScript. It only knows how to run WebAssembly. And so the way that people are getting around this is they basically pull a JavaScript engine off the shelf, which is written in WebAssembly, which then runs JavaScript within it. So it's like that, like Turtles all the way down apocryphal story.
It seems so silly.
Yeah.
Like that.
And it's like
the killer use case for WebAssembly is just to let us write more JavaScript.
I know, it's really in some ways frustrating. And I was like, wait, and it's really bizarre because the original version for WebAssembly started off as a variant of JavaScript. It was a subset of, what did they call it? I forgot what it was called before it was WebAssembly.
It was mscripted.
That's what I'm thinking of. Yes, exactly. And it basically took regular like C code and it compiled into this subset of JavaScript to execute like a virtual machine really fast. And that was the thing that kickstarted, hey, let's build this bytecode. And then the ironic thing they lost was the ability to run JavaScript. So yeah, what you have is a JavaScript function running inside a JavaScript runtime, which is called quick.js, which is itself running inside a WebAssembly container. So it's multiple layers of indirection. And they detailed a bunch of things in there that were really fascinating about how they work through those issues. Most notably, when you try to do it in, say, a naive approach, the size of the bundle gets really big because you're building every single function now has to have a little bit of quick.js in it, which is itself not big. And then you compile it to WebAssembly. And so they came up with some solutions for what people might be familiar with as essentially very similar to dynamic linking, which is if every program on your computer is using the same library, then why don't I just store that library once in my computer and all the other ones don't have to pull that all in? What we used to do with libraries like React or jQuery, which were commonly used and would all point to one repository, until that became
the same with like mono repos now do a similar thing.
Yes, yeah, very similar. So that was the number one thing I thought was interesting there. But they're also building an open sourcing part to their tool chain on it. It was a really impressive and in-depth walkthrough. If you go to his blog, by the way, I think he calls it like my brain dump on everything I know about WebAssembly that he just posted within the last week or so, that I also recommend checking out if you really loved this post. It's really in-depth. But the big takeaway here is the progress they're making and the whole ecosystem is making towards making JavaScript run better in WebAssembly, which I think should be great for everyone and something that's near and dear to, I think, a lot of the hearts of folks of us like myself who are close to the runtimes of the ecosystem. So that's my quick
so I would
overview.
be curious.
Yeah, go ahead.
Yeah, I'd be curious. Do you think that like developers will need to know anything about these internals, or is the idea to be able to just write JavaScript and have it like work? Is there anything that's going to be specific to this kind of these WebAssembly things that we're using?
Yes and no. I think the goal is that they don't have to. That's the holy grail. You already have that on the V8 versions of these platforms. There are issues that they have, which WebAssembly, I think, solves. And so ideally, the answer is no, you don't have to worry about it. So that's what we want to get to. I think there's going to be growing pains, though. There will be areas that will be, I don't want to say uncanny valleys, but there may be things that people have to be aware of. I'm in this runtime versus not. And it's, I think, going to be a little bit analogous to the early days of the web, where you might have had, if you remember, some browsers support some features and some browsers don't. And we still have that, actually, but not as bad. And now everyone is really aligned to overall standards, and it's just a feature or two off. Back when it was, they were completely like they would follow. I feel like thanks to things like the Winter CG group, it's going to be more like what it is today, which is if you're running in this browser, this feature might be available and this feature might not be in another, but the broad outlines are roughly the same. I think it's going to be more like that than what we had before, but that is the danger we got to worry about. So hopefully the answer is no, but don't be surprised if there's one or two like details you have to worry about.
Yeah, I'm looking at some of the code in the blog post now, and it looks like if you want to import FS, like the file system module that most people would use from Node, it's going to be from Javi/FS, and then they're going to try and implement that as close to the standard as possible, I would assume. I guess it's not really a standard, it's just Node, but as close to the Node APIs.
And that's where this other standard WASI comes in, which is WebAssembly or WASM only describes how to execute computations. It does not describe how do you talk to the file system. What is the actual function call you make? How do you send messages? How all like and it could, that all is very different from platform to platform, and WASI is an attempt to standardize it. And so is to a certain extent Winter CG. And hopefully, again, this is why I think we've learned as an ecosystem the collective memory of what happened when we had browsers that had different sets of standards, even though there was a standardization to a certain extent from W3C. I think we're going to try and prevent people from having to go through those pains, but there's that risk right now as companies are pushing forward and are ahead of where standards may be.
Yep. And then what do you think what's your kind of intuition for just how big of a performance gain you would get from this in comparison to both lambdas and other edge functions?
For the latter one, it remains to be seen. I think there's a lot of factors that go into it. There's performance it also depends on how the function is written, and there's always things like memory versus time trade-offs and things like that, and then how much resources are allocated to functions and those policies in terms of how you make sure that one function doesn't starve another, and you make sure you give equitable resources. And that may depend on your go-to-market model and whether you've got like a large free tier or not, and things like that, and how you isolate those customers. How it compares to serverless, I think that's a little bit remains to be seen. What people generally are using WASM and edge functions for are for things like middleware, and they're generally used in environments where let me back up because I'm glossing over a really important detail. I don't think it's really a question of WASM versus serverless. I think it's a difference of edge functions versus serverless, or edge functions versus cloud functions. It's about when do you run computation on the edge versus when do you run it in a more centralized data center in the cloud. Whether it's WASM or not, I think is a little bit orthogonal to a certain extent, not completely. And so I think there needs to be a kind of collective understanding in the ecosystem about when do you run code where. Just like we're starting to have this appreciation of things like the performance impacts of hydration, and it took our ecosystem a couple years to really start to appreciate that. I think it's going to take us the same amount of time to realize not everything should be an edge. So the canonical example I like to use is server-side rendering. It doesn't always make sense that you should do your server-side rendering in an edge function. And there are people who are like, oh, I'm looking forward to running server-side rendering there. And the reason you might want to not do that is imagine you've got a page that's the same for everyone. and you've got maybe 100 pops around the world running edge functions. And let's say you're able to do it fast enough that you can do it inside an edge function, because edge functions typically don't let you run as long as cloud versions of functions. Even if you do that, you're going to do the server-side processing, that compute cost, in 100 different nodes, right? If you get all hit from all across the globe. Now, if you did it in one cloud function, and then all the edge nodes had to do was just cache that result, you'd only pay for it once. So there are times where you've got to judiciously pick, and not everything needs to be an edge function. So things that make sense to do in an edge function are things that are closer to the user and get personalized to them. So an example of this is personalization of the content. So you might take a cached version from that cloud function that runs centrally, and then add on details about the user personalized. Like it might say, "Hi, Bob, welcome back" at the top in the login, right? You can add that at the top of the header of the screen in maybe a personalized edge function, because that's just for that user. It doesn't make sense to do it in the cloud, and it can pull from the cache immediately. And that makes a ton of sense. Another great example of form of personalization is authorization. So you might get a JWT token or an authorization token from maybe a centralized security server, but then your edge functions can decrypt that token and check whether that person is authorized to access some other resource right there at the edge. That's personalized to them, and that'll have lower latency. So I think the ecosystem kind of needs to get a intuitive feel, I should say, for when to use edge versus cloud. And there's some people who are already out there, but I don't think as a whole the ecosystem really is appreciating that. That's how I'd break that down. That's a really long answer, I think.
Yeah, no, it was useful. Yeah, so the main thing is going to be don't do computation on the edge if it's not really going to give you much of a gain, but will have a cost of having to duplicate lots and lots of compute.
Yes, use where appropriate. And we have a slide deck that's used with the right tool where it's appropriate. And it walks through some of those use cases that we talk folks through. But I think it's something the ecosystem will learn. Maybe we should jump to the cloud cold start analysis.
Yeah, the last thing I would say is I dropped another link to the Shopify docs for this, and it looks like you can spin it up locally and test it out, but you can't deploy them yet. So if you want to be one of the first people to try this out, this would be a good time, but you're not going to be migrating your company's production site anytime soon with it.
Unless yeah. Here's my hot take, by the way, on Shopify. I think it's really interesting, the platform they're building out. I do wonder if they're planning at some point to generalize it more than just beyond e-commerce. So here's my rough analogy. Amazon was an e-commerce company, and at some point they said, we built this great infrastructure, we should spin it out. And that became AWS. You can imagine it's like history rhyming if Shopify plans to do the same thing. Right now, it's very focused on e-commerce use cases, but it'll be interesting to see if in, I don't know, half a decade or so's time, if they start broadening out once they've nailed the e-commerce use case, or they just continue to go deep. So I'm really curious to see whether they go deep or broad, but it remains to be seen.
Yeah, I've been appreciative of the amount they've been investing in open source in general, and I think that they've done a good job of sourcing people who are already fairly established in the open source community. And yeah, I'll be curious to see, as you say, how this all shakes out, whether it becomes something more generic and more applicable to non-e-commerce things. That's usually when I would start talking about some of these projects, like hydrogen and stuff like that. People would be like, oh yeah, it doesn't really interest me because I don't do Shopify stuff or e-commerce stuff or whatever. And I was like, yeah, that may be true, but like they're actually creating cutting edge tech that could be used for lots of things. So definitely agree with you there.
Yeah, and they keep pulling in people that I have to imagine have ambitions beyond just e-commerce. To put it like I don't think Remix is only thinking they're only going to be the framework for e-commerce. I don't think some of the other folks they've pulled over from Google are thinking just beyond that. They're used to thinking about the developer ecosystem as a whole. My hot take on it.
Yeah, that's absolutely right.
Let's talk about the Lambda cold start analysis, though. How did you come across that one? And I thought that was really interesting. I'll tell you my thoughts, but I'll let you go first on that one.
It's a good question. I have a whole set of newsletters and things that I get filtered in through my Feedly. So this is just one that I pulled out. I actually don't really remember where it originally came from. But yeah, I've seen things like this for, like, back when I was working at QuickNode, there's one of these for blockchain, like for using Ethereum, you could connect to it through QuickNode, or Alchemy or in Fura. They all have slight different latencies and response times, and I think it's really useful to just have a quick like visual image to look at things and compare against each other, because when you're just like using these things by themselves, you may be getting like half a second cold start and you'll be thinking like, was that good or bad? And you kind of need to compare it to something to know. And so this kind of lets you, okay, if you're using, say, Rust, you could get potentially a 16 millisecond cold start. But if you're using Java 8, you could get 500 millisecond latency start. So yeah, this kind of tracks with my general intuition of what I would expect to be faster or slower. Rust and Go are the fastest. Java and .NET are the slowest. So yeah, like the leaner, more systems level languages do very well, and the larger we have a whole virtual machine inside of this language will perform slower.
Yeah, I thought it was interesting on multiple levels. It was interesting to see like the different node versions. So there's obviously what you called out, like Rust versus like Java, like the fastest versus the slowest. It's order of magnitude, more than an order of magnitude, more. Go is like 54 and Java is 10 times that. And that Go isn't even the fastest. Rust was, at least on the current benchmark. The other interesting thing was Node, the different
Nodes
versions
get
of Node.
slower.
Node is getting slower. So Node 16 was faster than Node 12, but Node 14 is slower than both of them. And Node 18 is nearly twice what the fastest version, Node 16, was. So it's interesting to watch. The newer versions, are they getting slower or are they getting faster?
Yeah, I would have a couple theories about that. I would say it might be either one, just because it's like support for that is pretty new. I think at most just like a couple months. So it may just be like AWS hasn't tuned their infrastructure to give good performance on this, because as more people use it, they'll have more data to optimize more hot code paths. Or it could be that Node 18 has a lot more stuff to support. We're adding things like fetch, we're adding things like a test runner. So I'm not sure if you can use like the test runner in the like a Lambda, but I know you definitely use fetch, and that's the idea. So I think as Node has now had to support Node stuff, and now new JavaScript stuff is probably getting to be a larger footprint.
Yeah, I had similar thoughts as well. More, I don't know, I'd call what we're describing now like tactically, but more strategically, just some things that struck me about the project were, like you said, lots of people do these, but what they've built is a evergreen source. Like it'll constantly be updating. And he has a GitHub page where it walks through that. So I think that's a really valuable resource to the community. It would be really great to see how these change and evolve over time. Maybe he'll add that. The other really fascinating thing to me was, because it's the thing I wouldn't have thought of. It's an element of delight, which is, if it was me, I would just put this in a table. And I thought it was really creative that they have that progress bar for each one is to reflect proportionally how long each one takes. So you get a visceral feel for how relatively slow or fast they are, like as a human in relation. So you can see, like, you count off the 4 seconds it takes the Java line to come through, but the Rust line comes by so fast you can barely see it. In fact, it's probably going faster than 16 milliseconds or slower than 16 milliseconds. I thought that was a really nice touch. There's a little bit way of how it renders that I feel like it doesn't quite convey that message. I had to think about it too much to appreciate it, which they can probably fix. But overall, I thought that was a really brilliant touch, and that just, it added a really valuable element of delight.
Yeah, no, that's cool. And like data visualization itself, I think it's a very underappreciated kind of thing, because it's easy to just put a bunch of numbers on a page, but that doesn't always necessarily resonate with people. So that's why you do bar charts and things like that. But with this, it's like an animation that's conveying something about the data, which is really cool.
Yeah, when we used to do, I've seen often, if you've done stuff in web page test, right? You do the side-by-side comparisons of the video of it loading. You can see the web page load faster on one versus the other. This to me was like the equivalent of that. It was really clever, and I thought that was really nice. That was, to me, aside from the data and all the other work they went in, it was like that one last Apple-like addition to it that just takes it to another level. So my hats were off on that part. I thought that was really cool.
Yeah, I wonder if the person who created this has a plan to ever do this with edge functions. That would be also interesting comparison.
Oh, yeah. If they're not thinking of, I'm sure plenty of people who watched it or saw this post probably are. We're a little wet past the halfway.
Speaking of Shopify is on fire. Shopify is amazing. Shopify is the best. Shopify is the mothership. But remakes React. Shopify loves React. Third Web, there's a commerce kit that it's with Third Web and Shopify to do some of the combination of like blockchain plus regular payment system with a React platform to customize themes built in, whatever. So I thought that was pretty cool. So Third Web's kind of main thing, their main squeeze is React. Shopify obviously loves React. A lot of people like React, so it's nice that kind of revolves around that. So you don't have to like relearn a whole new thing to be able to use that. So it's a thing that popped up in my emails, like looking at it. I thought that was neat too. But it goes along with your threads here. We're talking about DeFi stuff and their functions, which is obviously very cool too.
Yeah, it's actually, I didn't see it. This is interesting though, because I know Third Web and I interviewed a couple people there when I was working at QuickNote, had them on our Twitter spaces. And yeah, they're a great platform, very dev focused. They're very, if you're used to modern kind of dev tools, it'll be very familiar to you. And Shopify has actually a blockchain division, a team that's been working on that. So this makes a lot of sense for them to bring in something like this that is already kind of carved out that path of good DX building like dApps and stuff like that. And yeah, that's pretty cool. I think that the appetite for this kind of stuff is at an all-time low right now, but that's actually when the most interesting things usually get built.
So yeah, this is definitely in Anthony's wheelhouse more than mine, but I'm curious, Anthony, what do you think about the potential for, blockchain as a common e-commerce like transactional currency? It's been so volatile, like it seems it was supposed to be a currency, but it's become more an investment vehicle. Do you think we'll ever get to that point? What are your thoughts there?
Yeah, so there's a lot of different coins, there's a lot of different chains, there's
Yeah.
ways to do it where you're using something that does have kind of a stable value, like stable coins. Some stable coins have blown up, but some have
Yeah.
actually stayed consistently stable and have shown that you can do that. I think that it's a question of what use cases can you unlock by adding that. And I think if you get into this subject, you end up finding a lot of potential use cases, most of which probably won't pan out, but a handful of which will. I think ideally for the blockchain people, Web3 people, they would like it to be where anyone can pay any way they want for anything. And that's just like the goal. So having something like Shopify bake it in so that someone who was going to use their credit card could just send Ethereum instead would be really nice. And that's what's going to help bridge that gap between Web3 people and people who've never really interacted with it yet.
Let me rephrase my question. How far off are we from, do you think, a large number of consumers crossing the chasm on using blockchain to make payments for e-commerce?
Yeah, it depends on how you define large. I think that
Yeah.
it will continue to grow over the next 5 or 10 years, and then probably at a certain point start to plateau. So the
Yeah.
question is, where is it going to plateau? If it's going to continue to be a niche number of people who are enthusiasts and want to keep using it, or if there'll be like a critical mass of people who want to use it. Because I think to a certain extent, some people like it and use it and want it to be part of society almost as like a political statement. They want the ability to have a currency that's out of the control of the government. So that may be a larger percentage of people than some might think, depending on kind of what their priors are there. But it's never going to just become like money that everyone uses. Like it's always going to be some subset of the population, I think, that's going to use it, unless literally governments themselves implement their own digital currencies, which then everything would change.
Okay. Yeah, to answer your question, the way I define large is crossing the chasm. So like past the innovators, past the early adopters, so more than 15% of e-commerce transactions. So I'm actually Googling right now, what is the percentage of usage of the currency in a transaction?
Yeah, it's
But I
definitely going
can't.
to be way below that. And I would say it's probably going to be at least half a decade or a decade until we will get to that point, I think.
Okay. Okay, that answers my question. The other thing that was in the newsletter that was really interesting was the React.js documentary was released. It's an hour-long documentary about the history of React. I'll let you, Anthony, go first, and I don't know if you have any thoughts on it, if you got a chance to watch the full thing.
I have not watched it yet. I'm definitely going to, though, because I've seen other honeypot stuff and I think they're really legit. And I know my friend Michael Chan is featured quite prominently in it. So yeah, it looked like it was super high production value and people seem to enjoy it.
Yeah, this is one where I don't know if there are any spoilers, because you know how this story ends. But so I've watched all but the last 10 minutes of it. So I still need to watch the last 10. So maybe there's a plot twist at the end. One of the things that Michael makes a point of pointing out at the beginning is that people sometimes feel like it was inevitable React was going to become the dominant framework, and that's certainly not the case. And people often forget how much React struggled to gain acceptance, and there were multiple points along the way where you wouldn't have predicted the outcome.
Yeah, history
And
always looks inevitable in retrospect.
exactly. And it's especially for people who are coming to the ecosystem more recently, it just feels like it's part of the woodwork. And what it really does a good job, I think, of is contextualizing what history looked like before React and what React was railing against, which I think is really important to appreciate, especially if we are moving to a post-React world. So I thought that was really fascinating. And I like how they took what is a technical topic and really boiled it down to, I think, a narrative and a story that could be appreciated by somebody from any background, whether it was technical or not. And I think it's particularly challenging when you're writing a documentary about a framework. And I believe Honeypot did the one on Vue.js, so they've got some experience doing it. This might be their longest one. I think the Vue.js one was like 30 minutes. This one's over an hour. But I thought they did a really good job about communicating technical concepts in a non-technical way sometimes, without getting
Yeah, I
too
remember the
technical.
GraphQL documentary they did a couple years ago, and I thought that was at the time it was the best documentary I'd ever seen about a developer subject.
Oh, I remember when that one came out. I have not watched that one. But I'll give you an example. And it's really important for people to understand that was the thing React was coming against was, hey, it's really hard to keep track of all these different updates inside a browser with the current like tooling that we have. What if we just, this crazy idea they called it, that you don't even worry about keeping track of updates. You just conceptually as a developer, just you get to blow everything away every time anything changes and you rebuild it. And then React just does some magic to fix that so that you can do that efficiently. And there's this great statement, like somebody said it shouldn't work, but it does. And really the challenge that Facebook was feeling, which is, and I think people don't appreciate this now, like they were trying to build one of the first really 100% pure digitally immersive experiences inside a web page at such a scale of billions of users. Like everything else was, I'm trying to buy a product. Like there was an end goal. But Facebook needed to be a compelling experience just to keep you staying there for no other reason than just to keep interacting through the web page with your friends, or stay in the background. And so this is this long-lived web page that is trying to keep you there as long as possible. And so they have to figure out how to build a very complex application that when you think about it that way, you're like, oh yeah, I don't think anybody else really had to deal with those problems in the same way at that time. There might even be people approximating to it. And that was a problem that necessitated the creation of React. And I think there's two interesting things there. One is that there's a lesson there that you may not be facing the same business requirements and architectural constraints that Facebook is. So maybe React isn't the right thing for you because you're not trying to build something like that. Maybe you're trying to be like Google, where it's like they get in, they get out as quickly as possible. You're not trying to keep them there. In which case, maybe like the startup time of React on startup performance isn't as important, or is more important to you than it might be for the team that actually built it. The other key thing is it was interesting in my head to comparison and contrast the evolution of React with the AMP framework. Like React was really built for developer happiness and the ability of developers to build and scale great experiences in a scalable way. AMP was almost developer second. It was really built for user experience.
Optimized for developer sadness.
It was, yeah, you could almost say optimized for developer sadness. It said, but the way we're going to solve this, rather than giving developers a great playground, is we're going to restrict what they can do instead of enhancing their expressiveness. And it actually created magical performance-wise experiences, but it was too constricting to that developers railed against it. So I thought that was one of the interesting things that was going through my head when I was watching it. But I can definitely tell you, I've got like 10 minutes left on it, but everything I've watched has been really great and a fascinating story, and I definitely learned a thing or two. So
Yeah,
I highly recommend it.
Yeah, I definitely look forward to watching it. I would love for there to be like 10 times as many of these just for all sorts of frameworks and projects because there's always more to learn about the history of these things. It's like we have so much data and so much like content and things online, and like these things are all being built in the open, but it's hard usually to get like a good condensed explanation of just like the history of some of these projects. I definitely found that getting into all this stuff. So these things can be really useful for developers who did not live through this. And it's also really cool because I am going to watch this with my partner, who is someone who doesn't know anything about code and doesn't really understand exactly how the different things that I work with relate to each other. So I talk about React and I talk about React frameworks and Redwood and stuff like that. She hears all these terms, and hopefully this will give her a better idea of what I mean when I say React.
Oh man, as you're talking, I'm wondering if I should watch it with my kids. That might be just too much.
Yeah, that could be
for
really
them.
cool.
That could be 8 and 10. Maybe I need to wait a little bit longer.
Yeah, it's a little young.
Yeah.
You taught them any code yet?
Not really, but
Do you get them Scratch?
they actually have done Scratch, and they've done Minecraft
Okay,
Education Edition. And actually, it turns out their middle school requires computer science, which I was impressed by.
That's awesome. My middle school required Microsoft Word, so I learned that was kind of the equivalent of learning to code.
Yeah. I think when I was in school, they just called it typing. So I guess I'm dating myself. But yeah, I didn't even thought of it. The one other thing I'll say that's really valuable before I have to drop is how much, and I think this is a lesson for enterprise managers and people in non-Facebook companies, but just how much of like engineering management was really critical. There's a decision point, for example, where the Facebook stock price is really low. They've just built this. Sorry, what'd you say?
Said buy the dip.
We can't buy the dip. The stock price has gone low. This is back when they first IPO'd. They're under a lot of pressure, and they're like, do we rewrite the whole ads software and we don't do any additional product development for 4 months just to migrate to React? And it goes back and forth, and finally I guess it's the Facebook CTO says, okay, we'll bet on React. And they did a bake-off, and Netflix did the same thing a few years later. They're like, okay, let's do a 30-day contest, and we're going to build the next version of our platform for the next 10 years on either React or this other thing. I think it was Ember. And they did the bake-off. And I think it's a very, very powerful example of like how important these questions are in outside of, say, the biggest tech companies, and what we can learn for how they make those decisions. So with that, I have to drop, but I'll leave you in Anthony's great hands.
Yep. See you later, Ishan. Catch us next week. We will be talking with Ben Myers, I believe, about accessibility, 11D, things like that. So yeah, would love to see you all there next time. Thanks for joining.